Mathematics Level 4, Topic 3, Module 5. Topic 3, Space, Shape and Measurement. Module 5, Trigonometry, Part 2. Module 5, Session 1. Session 1 will cover Learning Outcome 3.3.4, Trig equations with compound and double angle identities. Learning Outcome 3.3.4, Trig equations with compound and double angle identities. Welcome back. So far in the previous module, we have used compound and double angles to determine solutions of expressions without a calculator and to simplify expressions and prove identities. Now we will use compound and double angles to solve trig equations in the range 0 to 360 degrees. When going through basic steps for solving a trig equation, remind students about the cast diagram again and how to use it to find all the solutions within the given range. Trig functions are periodic, which means that they repeat their values in regular intervals or periods. So trig functions can have more than one solution within a given range. We asked the lecturer to give us the steps for solving trig equations.
Firstly, you will isolate that specific trig ratio. If I can use an example, you might get a situation where you have 2 sine x plus 1 is equal to 0. So your very first goal here is to isolate that sine x, meaning remove the term of positive 1 over negative 1 and then divide by 2. That's phase number 1. Then phase number 2 is then you find your reference angle, which means you're going to find x, which will be arc sine of that, the positive value. Then step number 3 is you're looking at your cast diagram to see where sine will be negative in this specific one. And then you get your values. But now, if you consider, because that's what they mostly ask, the range, you consider between 0 and 360 degrees. Immediately, once you see that, you need to draw your cast diagram. Because your cast diagram will inform you in which quadrants those values will lie and also what the values then will look like. Just by looking at the cast diagram, even when you come to a certain stage, let me just explain this by means of an example. Sine of 5 theta is equal to minus 0.5. Immediately, when I look at my cast diagram, sine minus, based on my cast diagram, before I even start with any steps, my cast diagram tells me that my values will be, because of that negative, between 180 and 270. So in other words, I will get a value between 180 and 270. And the other one is I will get a value between 270 and 360. Because in those two quadrants, based on my cast diagram, sine is negative. Now, in other words, what does that tell me? That tells me, even just by looking at the question, I already have an idea of what my answers should look like.
To recap those steps. First, isolate your ratio on one side of the equation. Second, find your reference angle using the arc sine, arc cos, or arc tan function on your calculator, or by using special angles. Lastly, use your cast diagram to find your solutions. Let's take a look at a simple example as an illustration of these steps. Solve the equation sine x equals 0, 2. This means that we need to find all the values of x that will make this equation true. If we look at the graph of y equals sine x in the range 0 to 360 degrees and we draw the line y equals 0, 2 on the graph of the sine function, we see it touches the graph twice. So there are two solutions with the range 0 to 360 degrees. To solve the equation, first we use the arc sine function on the calculator to get 11,5369. This is our reference angle. It is very important that students understand how to use the reference angle. As 0,2 is a positive number, we turn to our cast diagram to find the quadrants where sine x is positive. We see that this is in the first and the second quadrants. So, we have two solutions to our equation. In quadrant 1, x equals our reference angle 11,54 degrees. And in quadrant 2, x equals 180 minus our reference angle 11,54, which is 168,46 degrees. If we take another look at our graph of the function sine x, we can see where our solutions fit in. Now, let's watch a lecturer talking a bit more about solving trig equations and then working through a more difficult example.
Now, the other tricky part here, and that's really tricking the people here. You have, say, for example, sine 5x is equal to 0,5. I'm just using it as an example. 5x, that is your reference angle, is equal to arc sine of 0,5, and you get, for example, let's say it's 30 degrees. I'm just using examples. Please, this is trick. The 5 theta is your reference angle. You need to move now to your cast diagram and then only divide by 5. And normally the people immediately, the reference, they divide. Please, we don't do that. You're becoming a mathematical criminal by doing that. Because by means of doing that, in other words, you're changing the procedure, and you will see, you will end up with funny answers. That's the first type of trig equations. Then you have the type of trig equations where you can use the same basics as in algebra. Two terms where one is a common factor. Obviously, you're going to factorize and apply the zero product rule, but then it links up to what I've just explained. And then you will have another situation where you have 3 terms, which must be equal to 0, which you can express as a quadratic trigonometric equation. And obviously, what do you do with quadratic expressions in algebra? You factorize, or you applying the formula method. You're doing exactly the same, but if you are unsure, sometimes it's express it and use your algebra symbols, because sometimes the ratios confuses the students. Sine squared x plus 2 sine x plus equals to 0. Let that sine x then equal to x, that the problem become known to you. And then you simplify it as you will be the case in algebra. And then you just back substitute with sine and you sort it out. And that's the basic. There's a variety of them that you can get. But just covering the basics in terms of that. And then just one thing to remember, you will get a factor where there's 2 different ratios. Please don't become heroic. Sin x minus cos x equals to 0. And now, we cannot find the value of theta if it's 2 ratios. So you need to simplify those 2 ratios to 1 ratio. And in that instance, please also don't go for cotan, because cotan is not on your formula sheet. Sorry, not formula sheet. It's not on your calculator. Go for tan. So always use the ratios that are on your formula, on your calculator. Sine, cos, and tan. So in the case of sine and cos, you're going to divide that sine into cos, which gives you the quotient identity for tan. And with the aid of that, you'll be able to solve that question. Now we move on to the solving of trigonometric equations. Let's consider the first example. Determine the value of theta if 0 degrees is smaller and equal to theta, which is smaller and equal to 360. That means that the angles values of theta must be between 0 degrees and 360 degrees. Now let's stand still there for a moment so that I can explain to you people what does that mean. The first thing, between 0 and 360 degrees means we need to apply the cast rule. And then I'm going to now step by step explain to you how this cast rule unfolds. We start here at quadrant number 1. That's between 0 degrees and 90 degrees. And in quadrant number 1, we will have our reference angle. And also in quadrant number 1, all trig ratios are positive. Then we move to quadrant number 2, which is between 90 and 180 degrees. In other words, the value of the angle will be between 90 and 180 degrees. And here you can clearly see it will be 180 degrees minus your reference angle. And in this instance, sine and its reciprocal are positive. Then we move to the third quadrant, which is between 180 and 270 degrees. This is your third quadrant, and the value here, we all can see it's greater than 180. So it's going to become 180 plus your reference angle, and tan and its reciprocal is positive there. And then the last quadrant is between 270 and 360 degrees, which is 360 degrees minus your reference angle, and cos and its reciprocal is positive there. Very important to note here, people, that your reference angle value will always be a value between 0 and 90 degrees. It's very important to note that. We just keep this diagram in mind, and now I'm going to start solving that, and then I will engage with this diagram in order to find the values of theta. Cos of theta is equal to cos of 2 theta plus 10 degrees is equal to 0.866. Step number 1, we need to find the reference angle 2 theta plus 10 degrees. How will we do that? 2 theta plus 10 degrees is equal to, I like writing the full word here, arc cos of 0.866. And if you punch that into your calculator, you will get a value of 30 degrees. And please, 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 this is your reference angle. Don't find theta here, please, because that's the confusion with some people. Your reference angle is 2 terms where we normally have 1. So when you find your reference angle, you keep the angle in that given form. And after you have found your reference angle, if you look at this whole diagram, in all 4 quadrants, reference angle is common. Can you see there? First quadrant, reference angle. Second quadrant, reference angle. Third quadrant, reference angle. Fourth quadrant, reference angle. That's why you cannot find any value here without having your reference angle first. And now you're going to focus on this. That 30 degrees means it's a positive 30. And we're looking at the ratio cos. And according to this Carr's rule, cos will be positive in quadrant number 1 and quadrant number 4, because it will be negative in quadrant number 2 and quadrant number 3. So now you make a statement. You say cos of that angle is positive. Because there it's given as positive in Now what I normally do is I draw a small line here and then I split it. And I'm going to focus on quadrant number 1 because that is where cos is positive. Quadrant number 1. Now, obviously, quadrant number 1, you're dealing only with your reference angle. So that angle there, 2 theta plus 10 degrees, is equal to your reference value of 30 degrees. Now, you must first remove the term and then the coefficient in order to find theta. Only now you find theta, not there. So 2 theta is equal to 30 minus 10. And that is equal to 20 degrees. So theta, now you need to find remove the coefficient, is 20 divided by 2. And that is equal to, we can say this is theta number 1, that is equal to 10 degrees. But cos is also positive according to your cast rule in quadrant number 4. So you're going to say quadrant number 4, which means that same angle, 2 theta plus 10 degrees is equal to, according to my cast rule, quadrant number 4 will be equal to 360 degrees minus my reference angle of 30 degrees. And that is equal to 330 degrees. Then I first need to remove the term, exactly the same, 2 theta is equal to 330 minus 10, which will be equal to 320, and theta therefore will be equal to 320 divided by 2, and this, if you use your calci, will be equal to 160 degrees. So the values for theta between 0 and 360 degrees in the first quadrant is 10 degrees, and in the fourth quadrant, second value, you can say theta 2 is 160 degrees. Now, people, just do yourself a favor, because sometimes you come out of the exam and you just say, I don't know. No, not here. Substitute the value, cos the theta value into there and see if you get that value. And then substitute the second value of theta into there and you see if you get that value. And then your equation there will balance. So you can test whether your answers are right. There's no statement there stating that you can't use a calculator. In fact, you must use it in order to get your reference angle. But you can even test. It's just as a tip. You can test your answer and then you can come out there happy. I got my marks.
And now for an activity in groups. Solve the trigonometric equations in question 1 and 2. While working through the solutions, think about how you would help your students with these questions. Let's watch a lecturer solving these equations.
Solve for all the values of x, an element 0 to 360. People, please, that is just another way of telling us that the angle should be between 0 and 360 degrees, meaning that it must be any value between 0 and 360 degrees. In other words, that means we're going to use all 4 quadrants on the cast diagram. And for all our trigonometric equations questions, we will use the cast rule. That's the reason why you've seen I've written it down already. Now let's look at the question. Cos 2x is equal to 3 sine x minus 1. Cos double angle equals to sine single angle. I think this examiner is gerook. That's normally what we think. But now, if you're looking at this double angle, according to my formula sheet, I can express this double angle in terms of sine by using formula number 15. Cos 2x, according to formula number 15, is exactly the same as 1 minus 2 sine squared x equals to 3 sine x minus 1. Lovely. Now, I can just rearrange everything. You can see sine squared and sine. Obviously, that brings me to the point of, in order to solve x here, I need to get, first of all, a quadratic trigonometric equation in terms of sine. Always first will be the square, minus 2 sine squared x, right? Then I'm going to move that 3 sine over. It means it's going to become minus 3 sine x. Then I'm going to keep that 1, which is positive, on my left-hand side. And I'm going to move that minus 1 also over. It become positive. And that must be equal to 0. The condition for solving a quadratic equation, immaterial, whether it's trigonometrical or whether it's algebraic, the equation must be equal to 0. Now, minus. Let's get rid of the minus by multiplying the whole equation now with minus 1. Minus times a minus gives you a plus. 2 sine squared x. A minus times a minus gives you a plus 3 sine x. Obviously here, people, you can see you will get plus 2. But times a minus gives you a minus 2. And that is equal to 0. Now, I just want you people to note something. I could have left that as is, and then I could have used straight away the formula method. But seeing that we bounded or restricted with time when we write papers, it's always better to go an easier route. If we look here, we have sine squared x, sine x, and a constant equals 0. So this is a quadratic trigonometric. Why I use trigonometric? Because we use trig ratios equation. Now, let's see if we can factorize that. You can either go via the route of factorization, or, as I've said, you can use the formula method. If the sign of the constant is negative, we will have two factors with different signs, negative and positive. And then the first one there will be 2 sine x, and obviously sine x. And now we need to look at the factors. When we subtract it, that will give me a positive 3. In other words, positive 2 times that 2 gives me positive 4, and then minus that 1, that gives me positive 3. And just a quick way of checking whether we are correct, a negative 1 times a positive 2 gives me a negative 2, which means our factors are correct. The same as in algebra now, we will apply the zero product rule. What does that mean? That first factor must be equal to 0. 2 sine x minus 1 is equal to 0. Oh, sine x plus 2 must be equal to 0. Let's find x here. Sine x is equal to negative 2. Oh no, invalid. Let me explain this first before I move on to the other side. People, why is this invalid? You can go to your calculator and you can press x equal to arc sine of 2. You will get an error, and then you will press your calculator even harder and you'll get another error. Then later on you'll check the calculator's gerook, but you gerook. Because, very simple, let's look at your sine diagram. The values must be between positive 1 and negative 1. Therefore, negative 2 is out of bounds. That's why it is invalid, or you can write impossible. You will never get a value there. Now in this instance, let's find x. 2 sine x is equal to 1. Obviously, sine of x is equal to a half. That means this here, people, tells you that you will have a positive value for sine, which means your value should be, you must be in this position, be able by looking there to determine what your value should be. Positive sine, your value should be a value between 0 and 90. That's going to be your first value. And where sine also positive, in the second quadrant, your second value should be a value between 90 and 180. If you get any other values outside that, then you are out of bounds. So let's first find our reference angle. X is equal to arc sine of a half, and in that instance it is equal to 30 degrees. That is your reference angle, which is also the value for your first quadrant. You don't need to calculate it twice. But now, sine is also positive. It's good to note this, that you know and you explain to the students where they get the other value in. I can use Q for quadrant, and then I can say 2. Where do you see that? You see that from your Carr's rule. And how will you find the next value? 180 minus that reference angle. You can then say, okay, this is x1, and then you can now calculate x2 is equal to 180 degrees minus that reference angle of 30 degrees, and that is equal to 150 degrees. And once again here, people, you can even test your answers. You can first put in the 30. That means cos of 60 is equal to 3 sine. Obviously, it's 30 minus 1. You will see left-hand side, right-hand side. And you can also put in the 150. Substitute x with 150, and you will see whether your left-hand side equals to your right-hand side to test whether your answers are correct. Solve the following equation for all values of x, which is an element of 0 and 360. That means we need to focus on all 4 quadrants. And we need to keep that in mind. So the very first thing is, if we need to solve an equation, your right-hand side must always have a 0. So we're going to say, okay, 6 sine squared x plus 2 sine 2x minus 1 is equal to 0. Sine squared x, sine 2x. So obviously we need to go to our formula sheet and get the equivalent of sine 2x. 6 sine squared x plus, remember that's 2, but times sine 2x is 2 sine x cos x minus 1 is equal to 0. So we're going to get 6 sine squared x plus, very important, 2 times 2, That gives you 4 sine x cos x minus 1 is equal to 0. What our students will do now, something is wrong here. We cannot solve this problem because we know once you have sine squared x, you must only have sine x. What about the cos x? And there's a 1. What does that mean? But 1, and this is the tricky part here, 1 can be expressed according to the formula sheet in terms of sine and cos. And it's very important to note that 6 sine squared x plus 4 sine x cos x minus, very important, what is 1 in terms of sine and cos? 1 is equal to sine squared x plus cos squared x and that is equal to 0. Minus, so now we need to multiply the minus out and then get our quadratic equation. Sine squared x plus 4 sine x cos x minus, and a plus gives you a minus sine squared x, and then a minus and a plus gives you a minus cos squared x. It's important that we always must note the minus sign because otherwise it will minus you in the exam. 6 sine squared minus 1 sine squared x, that gives me 5 sine squared x plus the 4 sine x cos x and obviously minus that cos squared x, sorry for that, cos squared x, and that is equal to 0. Now I'm having a quadratic. Sine squared x, half of it, sine x. Cos, double. So we're having a quadratic trigonometric equation with 2 ratios, sine and cos. My next step is I will need to factorize in terms of sine and cos. Obviously, you have a negative, so you will have 2 factors with different signs because that's what that negative is. And obviously, you will get here sine x and that 5 sine x, that gives you your first term. And then obviously you will have cos x, a positive 5 sine x cos x, and a minus cos x. That gives you a positive 4 sine cos x, and then a positive and a negative, that gives you your third term, negative cos squared x. That is just a way of checking whether you have factorized correctly. Now you're applying, no matter whether it's trigonometric ratios, you have 2 factors that multiplies and it gives you 0. So you're going to apply the 0 product rule, which is my first factor, sine x plus cos x. That is equal to 0. Oh, my second one, 5 sine x minus cos x, that is also equal to 0. Now, sine x plus cos x, people, there's 2 ways of doing this. But we will go for the simplest one. Remember, in trigonometric equations, you only need to have 1 ratio. Sine x is equal to a value, therefore we can find the value. Now, sine in terms of cos, you can either square it so that you can have 1 ratio, or I prefer this one, sine x is equal to, let's move the cos over, minus cos x. And then when I divide, I will do all the steps now. Sin x. I will do it this side. I'm going to divide it by cos x. Why do I do that? Because sin over cos is the reciprocal identity for tan x. And if I divide there, minus cos x over that cos x. So can you people see then? I express that now, tan x. I'm just doing this side alone, then I'm going to focus on the other side so that we can understand what's happening here. Tan x is equal to minus 1. Very important now. What do we need to find first here? The reference angle. This minus 1, if I can come back in here again, you people still remember the cast diagram? You still remember the node and the 90, I'm just recapping quickly, and the 180 and the 360. Tan, according to this diagram, is negative in quadrant 2 and in quadrant 4. It means that I will get a value there between 90 and 180, and I will also get a value there between 270. That's 360. Sorry for that, that's 270. 270 and 360. So it will either be 90, 180, in between 270 and 360. But I first need to find my reference angle. So I'm going to say tan is equal to arc tan of 1. And this is equal to 45 degree when you go to your calculator. So obviously, let's find the first value then. X1 will then be equal to, in my second quadrant, it will be 180 minus that 45. And that's going to give me 135. And then in my fourth quadrant, it's going to be equal to 360 degrees minus 45. And that will give me 315 degrees. This is the two values where tan is negative. Now let's do the other one here, exactly similar like that side, but now I'm going to simplify it because you already know from there I've divided by cos. So I'm going to first say 5 sin x is equal to positive cos of x. Obviously, when I divide by cos, you will agree that I will then have 5 tan x, which will be equal to 1. So tan of x will be equal to 1 over 5. It implies that x will be equal to arc tan 1 over 5, and that is equal to, when you go to your calculator, you will get 11.31 degrees. This is your reference angle, but this is also one of the values because tan is positive in the first and in the third quadrant. So I can then say x number 3 is equal to 11.31 degrees. What will x number 4 be? It will be equal to, if I look at my third quadrant, it's going to be 180 degrees plus 11.31, and that is equal to 191.31 degrees. So we have 4 values for x here, where x is negative, 135, 315 degrees. And then where x is positive, 11.31 and 191.31. This is a very interesting example because we have focused on all 4 quadrants of the cast diagram.